So he's telling coefficient of friction bead and the rod is uniform everywhere. Find the velocity of projection of the bead. So when the bead arrives here, it will have the velocity v1. When the same bead arrives here, it will have velocity v2. I think you have to go back to work point G chapter. They're like a same charge, a bead of mass M having same charge Q. Same charge Q means, shall we take it positive or negative? Positive only. You take like this. Let this be positive charge. So how the friction will act on the bead? Opposite its velocity. So why the friction will come? Because if you look at the electrostatic force in this position, let's take some separate diagram. The bead will come in contact with the rod like this, no? Okay, this electrostatic force will be acting like this. At different positions, no gravity. There's no effect of gravity here. So the electrostatic force will press. The upper part of the bead will be in contact with the rod. Just we'll we'll look at the thing, that one. So here component of this, say some theta. So Fe cos theta will press it, no? Here I'll get normal content. Because of this, here I'll get a friction. Why do the friction will come? Because O will provide normal contact. And a component of the friction, a component of electrostatic force will act in this direction. So it was given some velocity. Let's assume that. So definitely the friction and this electrostatic force does negative work. So the kinetic energy keeps on decreases. It'll have V1 here and it'll have V2. So we know work done by the friction when it moves from point 1 to 2. So well, that friction depends on velocity of the bead. Well, the friction depends on velocity of the bead. I'm just asking friction on what is F is equal to. F you are going to write mu n, no? That's all. So, and what is n is equal to? Fe cos theta. So theta in fact variable. So is it a constant friction or variable friction will act? Theta is varying. Okay, now we have to. So will you take help of any work done concept? So as it moves, theta will vary. I'll integrate. So what work the friction does when the charge particle moves from 1 to 2 is the same work the particle will do when it moves from 3 to 1. That you have to put it. So this is about when charge particle is here, where the electrostatic force is acting in this direction. Now somewhere in this position, in this region. how the electrostatic force will act like this. The point charge is here. Electrostatic force will act here. So the same theta, the same normal contact, and the friction will act in this direction. Here, Fe sine theta will act in this direction. The component of electrostatic force will act in this direction. So when it moves from 1 to 2 or 3 to 1, what is the displacement? Will be same. And what is the magnitude of friction acting? Here also, I think the same thing. The n will not change for both the diagrams. So this is when the rod, the particle is between 1 and 2. This is when particle is between 3 and 1. So somehow, can you calculate work done by friction here? Yes, the same amount of work the friction will do here. Compare things, I think you can manage. You need not to bother all any other condition. Okay, fine. So to avoid mathematics, I'm just taking. So let's focus on 1 and 2. Kinetic energy at 1, interaction potential energy at 1. And when it moves from 3 to 1 or 1 to 2, what is the work done by friction? Should be negative. So the equation, I'll proceed to writing set of equations. Okay, no? So let's write equation. So here kinetic energy at 1, m v1 square by 2. Interaction potential energy, kq square by d, should be equal to kinetic energy of particle. This is given for us. Interaction potential energy, kq square L, plus work done by friction. So what is the work done by friction will be? We don't know, leave it. No problem. No need to calculate. So can we get work done by friction? Yes, the same, the work done by friction as it moves from 1 to 2. One very important thing I'll conclude. Work done by friction as it moves from 3 to 1 is equal to work done by friction as it moves from 1 to 2. So what all that I'll calculate from here. I know V1, V2, all the things are given, I'll get this one. So I'll write the equation now. M, this is what the unknown thing, no, which we have to calculate, V naught. So mv naught square by 2 plus kq square L is equal to m v1 square plus k q square d plus work done by friction when it moves from 3 to 1. Substitute that and solve, you'll get the required answer. But before that, you are supposed to analyze this diagram, how that normal contact, how the friction will act. Here it will have velocity in this direction, some v dash you call it. Just substitution type, nothing. So only thing is this conclusion is